All right, here is number 20. And so the question says, what is the maximum height of the ball, and what was the height the ball was tossed from? Okay, so if we maybe zoom in a little bit here, the maximum height of the ball is where it's the height of where this vertex is at the top. So this point here, it looks like that is at, let's see, 8, 10, 12. Maybe that's, if we're going by twos, 2, 4, 6, 8, 10, 12, 14. Yeah. So that the height is 14, and I'm assuming that is feet. So that's the maximum height equals 14 feet. Okay. And then the second question is, what was the height of the ball? What was the height the ball was tossed from? So it looks like it is starting here at that spot right there, and that looks like that would be at 6. So tossed from 6 feet. All right, and that's it. All right, here's number 21. A school club is raising money for a trip and needs to reach $10,000. Their fundraising will produce a profit of f of x equals 435 plus 1200x, where x is measured in weeks. What is the meaning of the coefficient 1200? All right, well, since that the 1200 is the coefficient of x, and x is how many weeks, and we're talking about profit here, so it appears that for every week x, you're going to be raising $1,200. So basically, we're saying that the 1,200 means you're raising $1,200 is raised per week. So that's the amount of money per week that you would be raising. And number 22, we have this expression, x plus 2 divided by x squared plus 5x plus 6. We have to simplify it. So to simplify it, we just factor the denominator. So what multiplies to 6 and adds up to 5, and that's 3 and 2. So that's going to be x plus 3 times x plus 2. And then we can simplify by dividing the x plus 2 on the top and the x plus 2 on the bottom. They'll end up canceling each other. So that leaves us with 1 on the top and x plus 3 on the bottom. So that's 1 over x plus 3. So that is the simplified answer. So that's 1 over x plus 3. Okay. And then the excluded values is going to be whatever makes the denominator 0 in the original expression. And so in the original expression, we ended up factoring it into x plus 3 times x plus 2. That's in the denominator. Then we have to set each of them equal to 0. So x plus 3 is 0, so we get negative 3. And if x plus 2 is 0, we get negative 2. So those are your excluded values, negative 3 and negative 2. Number 23, it says to multiply these two fractions. So to multiply, we'll just multiply straight across on the top using the distributive property. So q times negative 3q is negative 3q squared. And then 2 times negative 3q is negative 6q. Then on the bottom, we multiply those straight across. So negative 5 times q is negative 5q, and negative 5 times negative 2 is positive 10. And then the excluded values is whatever makes the denominator 0. So if I take negative 5q plus 10 and set it equal to 0, I'll have to subtract 10 from both sides. So that's negative 5q equals negative 10. Then I'll be dividing by negative 5. So q is negative 10 divided by negative 5, which is positive 2. So that is an excluded value. Okay, so the excluded value is q equals 2. For number 24, again, it was hard for me to determine what was between the x and the 2. So I just assumed that it was a positive there, a plus. And I also wasn't sure what was in between the fractions, so I'm assuming that it was a minus. Okay, so I hope that is correct. All right, we need to get a common denominator. The least common denominator is actually x plus 2 times x minus 3. It's the product of the two denominators. All right, so what we need to do is take the first fraction. It already has the x plus 2, so it needs to be multiplied by x minus 3 on the top and bottom. So distributing 9 times x is 9x, and then 9 times negative 3 is negative 27, and that's over x minus 3, x plus 2. We have minus. All right, and then the second fraction has the x minus 3, so it needs to be multiplied by x plus 2 on the top and bottom. Distributing negative 3, all right, want to be careful there because the negative here affects the 3. So that's negative 3 times x. Or actually, no, that's okay, because we actually brought the minus down here, so that's okay. So we'll just treat that as positive 3x, all right, since the minus is already here. So that's 3x, which is 3 times x is 3x. 3 times 2 is positive 6, and that is over x minus 3 times x plus 2. All right, we're going to combine the like terms in the numerator. So that's the 9x and the 3x, but it's being subtracted. So that's 9 minus 3 would give us 6x. And then we're going to combine the negative 27 and the 6, but the 6 is also being subtracted. All right, so that's minus 6. So negative 27 minus 6 is negative 33, or minus 33. And then that's being divided by the denominator of x minus 3 times x plus 2. And that is it. Number 25 is asking, says, what is the solution to the equation? All right, so we need to solve the equation. We'll add 10 to both sides to start. Those cancel on the left. So we have square root of x plus 8 on the left is equal to negative 4 plus 10 is 6. And now we have to raise both sides to the second power to get rid of the radical here, the square root. So the radical of x plus 8 squared is just x plus 8. The radical goes away. And then on the right side you have 6 squared, and that's 36. Now we can subtract 8 from both sides. 36 minus 8 is 28. And that's x, so x is equal to 28. We can double check that. Doing mental math, we substitute the x here for 28. 28 plus 8 is 36. The square root of 36 is 6. And then negative 10 plus 6 would be negative 4. So that does work. And number 26 is asking, what does the imaginary number I represent? Well, I is equal to the square root of negative 1. Because in the system of real numbers, the square root of negative 1 does not exist. So we have the imaginary number to represent the square root of negative 1. All right, and that is it.